Hey guys, so welcome back. It's Bieker the Science Tutor, and I'm here today to teach you guys about alkanes, alkenes, and alkynes and the naming process of it. Welcome back from the last video. We talked about the hydrocarbons, the simple ones, and the hydrocarbon chains. So today, hopefully you guys have your acronym and are able to say your own, or you could repeat mine. So a good way for me to memorize this is: monkeys enjoy pretty bananas. Therefore, I can remember the order it's in and remember that methane has 1 carbon, ethane has 2 carbons, propane has 3 carbons, and butane has 4 carbons, all in order, all simple like that. Don't forget that there's also longer chains, of course, so it's pentane, hexane, heptane, octane, nonane, and decane. Therefore, but these are the ones that we want to focus on now. This is for the learning curve too. And what we're going to learn today are different functional groups of alkanes, alkenes, and alkynes. Once again, last video we talked over about how the ane at the end is interchangeable, and now you'll learn why. So let's begin. So by definition, alkanes all have single bonds. Alkenes, by definition, have at least 1 double bond. Alkynes, by definition, have at least 1 triple bond. So the alkyne will always trump over the alkane. Alkynes will always trump over the alkenes. But we'll get to that part of what trumps what later. Just know that if there's a single alkyne or single triple bond, it's an alkyne. An easy way to remember this, I came up with something easy for me to remember. So Y for an alkyne, Y, in English you spell Y, W-H-Y, which has 3 letters. Therefore, there's 3 bonds. So Y, 3 bonds. E is in between 1 and 3. Therefore, it's 2 bonds. A in English is A, of course. So there's 1 letter and therefore 1 bond. And alkanes are what we're used to saying. So you have single bonds, double bonds, and triple bonds. Methane, ethane, propane, butane. We're not going to mess with methane too much because we're going to see this more of as an addition part, so we're just going to leave that here, but we're not going to really mess with it. Ethane, we're going to see how heat can change. Propane, of course, and butane. So I'm gonna go ahead and talk to you guys about the simple way to do these things. So I like separating my column, my last 3 word letters like this. That way you could just interchange a single letter. So I'm gonna go ahead and add lines, and we're gonna see if we can figure this out together. So let's see this. So this is obviously has 2 carbons. So you have 1, 2, but it's not a single bond. So therefore we know that it can't be ethane. So we're going to count the bonds. 1, 2, 3. There's 3 bonds. That means it's an ine. So we go over here to the ethane and we change it to an ethyne. And then I also wanted to let y'all know also that if you guys remember from last video, carbons all have 4 bonds. So this carbon here now has 1, 2, 3 bonds. So that means it can only have 1 hydrogen, as opposed to a regular ethane that can have 1, 2, 3 hydrogens. So it loses the hydrogens because it's now the carbon is more full with the bonds. So, but that's not necessary, right? Like I said, that it's suggested. So unless said otherwise, it is already suggested that their hydrogens are there. There's 1 hydrogen, 1 hydrogen. So what is this molecule? So we gotta do a check. So there's 1, 2, 3 carbons. So we know it's pro. They're all single bonds. So A has only 1 letter, 1 bond, single bonds. Therefore it is a propane. Therefore it's correct, just like that. Now the butane, we have 1, 2, 3, 4. We have 4 carbons, and we have a double bond here and a double bond here. Now, this is a little tricky. I throw it at you guys, so let's see if you guys can figure it out. If you can figure it out before me, awesome. So we're going to count our carbons, 1, 2, 3, 4. We know it's a butte. So there's a double bond on the 1 carbon, and there's a double bond on the 3 carbon. So I'm going to go 1, 2, 3, 4. I could also go this way, but it'd be the same. Because it flipped, it'd be the same. It'd be on the 1 and 3 carbon anyway. So how do you write this? So we know that it's I don't know if you guys got it yet, but we know that it's a butene because it's double bond. There's no 4, so there's no mixture. You can't go 4, okay, there's 4 because it's 2 and 2. No, it's still butene. So but instead we're going to write it like this. So you have 1 double bond on the 1 carbon, excuse me, and 1 double bond on the 3 carbon. So we know it's a 1,3 butene. Therefore, we know that there's a double bond here on the 1 carbon and a double bond here on the 3 carbon. It's pretty easy. So you just substitute it, and that's a butene. It's a 1,3 butene. That's a propane, and that's an ethine. So something I wanted to keep in mind for the triple bonds, the alkynes. Alkynes have torsional strain. So, I mean, they all have torsional strain, but this one has extreme torsional strain. So, it's, so let's see. So, it has torsional strain, so you have a triple bond. So, it's really sturdy. Like, it doesn't rotate freely. So, therefore, it's always going to be linear. It's always going to be linear. It cannot rotate like the rest of them. So, I'm going to give you guys an example. I'm going to give you guys a butane to where you guys can easier see it. And the way it's written, because it's going to look funky. It's going to look different. So, different from what we're used to. So, this is a butane. Some professors will not accept. Some professors will not accept this because it does not show that it's a 180 degree. So therefore, you need to make sure there's a 180 degree. It's linear. It's always linear because it cannot bend. It cannot twist. It has torsional strain. Torsional strain. So you got to count your carbons like this. This is a butene. So you may or butane. So you may ask me, okay, well, Adam, where are the carbons at? I'll see 1, 2, 3. Okay. Well, let me show you. So you have 1 carbon here, 1 carbon here. That's 2 carbons. Now, right here, there has to be carbons because that's where the triple bond's at. So it's 1, 2, 3, 1, 2, 3, 4. There's 4 carbons. Therefore, it's butte. There's a triple bond. That's where it's an alkyne, and it'd be a 2-butane molecule. And don't forget the hydrogens. So this carbon would have 1, 2, 3, 4 bonds. Therefore, it would have no hydrogens. This would have hydrogens, H, H, H. This would also have 3 hydrogens. So don't forget about those, that with bonds, it takes away hydrogen, because carbon's only like 4 bonds. So don't forget that. That is very important to know. So next time we're going to go over cyclos, which should be fun. We should go over more naming, more strenuous naming in the upcoming videos. We're going to add cyclos in. I'll put it in the methane to where we can make methane, or we can make different portions of the methane molecule. But for right now, this covers mostly all you need to know about alkane, alkene, alkyne. Go ahead and use what I use. A, single letter, 1 bond. E is in between 1 and 3, therefore it's 2. Y, WHY, 3 letters, 3 bonds. Thank you guys very much for watching my video. It's Adam the Science Tutor. Please subscribe, and I'll see you guys next time. Later.